So we were cut off earlier, so we're going to talk about practicing a Lewis structure, and we're going to do it with ammonia. So when I figure out the valence electrons for ammonia, I have 1 times nitrogen. Nitrogen has 5 electrons, plus 3 times hydrogen, and hydrogen has 1 electron. So that's going to be a total of 8 valence electrons that I can use for ammonia. With the ammonia, we have nitrogen goes in the center because hydrogen can never go in the center. So I'm going to put N, and I'm going to do 1, 2, 3. Okay, so I've used 2, 4, 6 electrons out of the 8. Again, I cannot put more electrons with hydrogen because it can only have 2, and the 2 are in the bond. So the extra electrons are going to go on the nitrogen, one lone pair. I check my octet. Of course, hydrogen only needs 2 and nitrogen needs 8. So we have the octet for the nitrogen, and this is a valid formula for ammonia. Let's try another one. Let's look at sulfur dioxide this time. Okay, so SO2. Now, with SO2, we're going to figure out the valence electrons. We have 1 sulfur. Sulfur has 6 valence electrons, plus 2 oxygens. Each oxygen has 6 valence electrons. So that's 12, 18 electrons. So sulfur dioxide has 18 electrons. I'm going to do my skeletal structure where we have sulfur in the center, oxygen, oxygen. I've used 2, 4 of the 18, so I'm going to start placing electrons on the outer elements, starting with the most electronegative, but they're both oxygen, so it's the same. So I've got 2, 4, 6, 8, 10, 12, 14, 16, and so those oxygens have octets, so the other 2 are going to go, we go back to the center and put them there. So if I count, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. We have a problem though, because I notice that both oxygens have 8, 2, 4, 6, 8, 2, 4, 6, 8, but my sulfur only has 2, 4, 6. And since each oxygen is the same, remember what we're going to do is we're going to take from the rich and share with the poor. So I'm going to take, it doesn't matter which one, I'm going to take and share. So here we'll have oxygen, double bonded sulfur, single bonded oxygen, and then 1, 2, 3, 4, 5, 6, and 2, 4, 6. So let's count and make sure they're all there. 2, 4, 6, 8, 10, 12, 14, 16, 18, and then check the octets. 2, 4, 6, 8 for that oxygen, 2, 4, 6, 8 for the sulfur, and 2, 4, 6, 8 for this oxygen. So this is the structure for sulfur dioxide. The next one, let's look at something like looking at a polyatomic ion. So if let's pick a polyatomic ion, let's do carbonate. So carbonate would have, it's CO3 2-, so it's a polyatomic ion. But remember, this is actually a covalent compound with 2 extra electrons. So I count my electrons. I have 1 times 4 electrons for carbon, plus 3 times 6, that's 3 times 6 electrons for the oxygen, and then we have 2 extra electrons, so I add 2 electrons for that -2. 3 times 6 is 18, plus 2 is 20, plus 4, so that's 24 electrons. Now again, carbon's going to go in the center, And I'm going to draw 1, 2, 3, 1, 2, 3 oxygens. And then I start placing electrons. I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons. Okay, so I've got all my electrons, I've used them. I look for my octets, 2, 4, 6, 8, and each oxygen is the same, so there's 8 on those. But my carbon only has 2, 4, 6. So I'm going to take from the rich and share with the poor. Now it didn't matter which oxygen, I mean they're all the same. I just decided to pull from the top one. So the structure that is valid would be a carbon, double bond to an oxygen, single bonded to an oxygen, single bonded to an oxygen. Now let's make sure this is a valid structure. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons, so I've used my 24 electrons. 2, 4, 6, 8 for that oxygen, 2, 4, 6, 8 for this oxygen, 2, 4, 6, 8 for this oxygen, and then 2, 4, 6, 8 for the carbon. So this is valid. The only thing we need to add is that anytime that it is a polyatomic ion or an ion, we have to put it in brackets and give it a negative value. Okay, let's look at one or two more. Let me see. How about HCN? So HCN, hydrogen cyanide. Now when I look at this, I see that I've got one hydrogen with one valence electron plus one carbon with 4 valence electrons plus one nitrogen with 5 valence electrons. So 5 plus 4 plus 1, that's 10 electrons that I can use. Now, remember, hydrogen can never go in the center. Carbon is less electronegative than nitrogen, so I'm going to put carbon, nitrogen, hydrogen. Now I've used 4 of the 10, so I start putting lone pairs around atoms at the outside. Do not put any more on hydrogen. Hydrogen already has its 2 from this bond. So I go, so this is 2, 4, 6, 8, 10. So now I count, make sure 2, 4, 6, 8, 10 electrons. 2, 4, 6, 8 for the nitrogen. 2, 4 for the carbon, so it doesn't have enough. 2 for the hydrogen, it has enough. So again, I take from the rich and share with the poor. So the first one I will look at is going to be carbon, double bond to nitrogen, and then we have this. I've taken this and put it here. So I count my octets, 2, 4, 6, 8, nitrogen's good, 2, 4, 6, carbon still not good. So take from nitrogen and share with carbon. So I'm going to have H, C, triple bond, N, lone pair. Because I only took one of the lone pairs and shared it. So we have 2, 4, 6, 8 for the nitrogen, 2, 4, 6, 8 for the carbon, and then 2 for the hydrogen. So this is the correct structure. And we will stop Lewis practice there, and we will start the next video. Thank you very much.